Hello everyone. Today we are going to study Fourier's law of heat conduction. This is my lecture number 9 on differential equations and its applications. I would like to request to all of you to subscribe channel on engineering mathematics to get latest updates and videos on it. In first 8 lectures, we have already seen Introduction to differential equation, then exact differential equations, equations which are reducible to exact differential equations, then linear differential equations and equations which are reducible to linear differential equations. And in the application part, we already seen Newton's law of cooling, then application of differential equations to orthogonal trajectory, and in this lecture we are going to study application of differential equations to Fourier law of heat conduction. The basic principles involved in conduction of heat are: heat flows from higher temperature to lower temperature. The quantity of heat in a body is proportional to mass, temperature and specific heat. Then Fourier law of heat conduction states that the heat flux Q in calorie per second through an area A, which is in centimeter square, is proportional to the temperature gradient normal to the area and its area. So if Q is flux quantity of heat, so it is Q is equal to thermal conductivity into area into temperature gradient. So heat flux Q is product of thermal conductivity, area and temperature gradient. So mathematically we can write Q is equal to minus K is proportionality constant. So minus Ka into dt by dx, where A is the surface area and dt by dx is temperature gradient. So it is already shown here. So if we consider a pipe which is circular, cylindrical, we can say, let radius of cylinder be x and length 1 centimeter. Then we have surface area of the cylinder which is given by A is equal to 2 pi x square centimeter. So generally we are taking pipe which is a cylindrical pipe and we are taking area as 2 pi x. So with this information, we can go for solving problem based on this. Problem number 1. A steam pipe 20 centimeter in diameter is protected with covering 6 centimeter thick, for which the coefficient of thermal conductivity is K is equal to 0.0003 calorie per second in steady state. Find the heat lost per hour through a meter length of pipe if the inner surface of pipe is at 200 degrees centigrade and outer surface of covering is 30 degrees centigrade. So just by observation, we can see that this problem is based on Fourier law of heat conduction. So we need to apply standard formula, and that is Q is equal to minus Ka into dt by dx. So here area is 2 pi x. So from this we can calculate dt, which is equal to Q divided by 2 pi k into dx by x. So this is a variable separable form of the equation. So we'll see what is given to us. We have given radius as diameter is 20 centimeter. So radius will be 10. So when x is 10, temperature is 200 degrees centigrade. And when there is a 6 centimeter thick covering, means 10 plus 6, that gives 16. When x is 16, temperature there maintained at 30 degrees centigrade. You can easily see through this diagram. So this is a pipe and this radius, this diameter is 20 centimeter, means radius is 10, and this 6 covering is 6 centimeter thick. So here when x is 10, temperature is maintained at 200 degrees centigrade. When x is 10 plus 6 means 16, temperature is maintained at 30 degrees centigrade. And so therefore what is asked in the problem? To find Q. So we write its mathematical form. We write this equation and we know we have to integrate it. So dt, integration of dt, which is equal to minus q divided by 2 pi k integration of dx by x. Now what are limits? When x is 10, t is 200. So when x is 10, lower limit, t is 200. You can easily observe it. When x is 16, t is 30. So we write integration in this form. And now we simplify this. So we write same equation over here. dt integration is t, but it is 30 minus 200, means minus 170. This is equal to minus q divided by 2 pi k as it is. dx by x integration is log x and limits are 10 to 16. So if you solve this, minus q divided by 2 pi k, for upper limit it is log 16, minus for lower limit it is log 10. So q is equal to, from this, 170, because minus sign will go. Minus of minus is cancelled. Q into 2 pi k, yes, cross multiply. 170 into 2 pi k divided by log a minus log b is log of a by b. Means log 16 minus log 10 is log of 16 by 10. Means log of 1.6. So that's why we have q is equal to 170 into 2 pi k divided by log of 1.6. So that gives 170 into 2. Pi means 3.14. K value is given in the problem as 0.0003 divided by 1.6. That gives, if you calculate this, 0.68144. And required heat loss per meter length of pipe, which is per hour. So it is what? Q, required heat loss is Q into 100 because of meter length. Centimeter we have to convert it to centimeter, into 60 into 60. We have to convert hour into seconds. So that's why it is Q into 100 into 60 into 60. And if we calculate that, we'll get 245,318.95. So this is your final answer. It is required heat loss. Required heat loss is 245,318.95. Okay. So with this, now we can go through some more problem, and here unit is calorie per second, obviously. So problem number 2. pipe 20 centimeter diameter contains the steam at 150 degrees centigrade and is protected with a covering 5 centimeter thick, for which K is equal to 0.0025. If the temperature of the outer surface of the covering is 40 degrees centigrade, find the temperature halfway to the covering under steady state conditions. So, we have to apply Fourier law of heat conduction, and we have to see that what is given and what is asked. So, first and most important part is the formula. So, by Fourier law of heat conduction, Q is equal to minus Ka dt by dx, and here area is given by 2 pi x, where x is the radius. So, dt is equal to, from this, we are trying to write it in a variable separable form. dt is equal to minus q divided by 2 pi k into dx by x. What is given when x is 10? Because here 20 centimeter diameter means radius is 10. Temperature is 150. So when x is 10, T is 150. When x is 15, because we have got 5 centimeter thick covering, I think. Covering, yes. Covering of 5 centimeter thick. So when x is 15, T is 40. You can easily observe this in this diagram. So this is 10 centimeter, and here temperature is maintained at 150 degrees centigrade. Yes, the temperature is maintained at 150 degrees centigrade, and covering is 5 centimeters. So this is what? This is 15. So when x is 15, temperature is maintained at 40 degrees centigrade. So to find Q, what we do is we write this equation again. So dt is equal to minus q divided by 2 pi k dx by x. So we have to integrate it. So integration of left side as well as right hand side. So when x is 10, just observe this, t is 150. So when x is 10, t is 1. When x is 15, t is 40. So we have to simplify this. So dt integration is t, means 40 minus 150, that gives minus 110. This is equal to minus q by 2 pi k as it is. Integration of dx by x is log x. Limits are 10 to 15. Or that gives minus q divided by 2 pi k. Log 15 minus log 10. As we know, log a minus log b is log of a by b. So it is log of 1.5. So minus 110, which is equal to minus q divided by 2 pi k log of 1.5. So equation number 1. Similarly, we have to find actually when x is halfway through the covering. This what? It is over here. Yes, halfway through the covering is, this is 5 centimeter and this is 10, and halfway through the covering is 12.5. So when x is 12.5, we have to find what is t, and for our convenience we assume t is equal to t1. So dt, this is equal to minus q divided by 2 pi k dx by x, and x is 10, t is 150. And x is 12.5, t is t1. So t1 minus 150, because integrating this, upper limit is t1, lower limit is 1. So that's why we have t1 minus 150. This is equal to minus q divided by 2 pi k. Integration of this is log x. Limits are 12.5 to 10. So it is minus q divided by 2 pi k. Log of 12.5 minus log 10. We know log a minus log b is log of a by b. So that's why it is 12.5 divided by 10 is 1.25. So T1 minus 150 is equal to minus Q divided by 2 pi K log of 1.25. So if you denote this by 2 and then if you take ratio 2 by 1, means if you divide it like this, T1 minus 150 divided by 110, yes, and Q divided by 2 pi K get cancelled obviously, then it is log of 1.25 divided by log of 1.5, yes. Here because we have what minus sign over here and here both terms having minus sign, so there will be one minus sign. So it is T1 minus 150 divided by 110, this term divided by this, and minus sign we shift to other side, otherwise this will get cancelled. So it is log of 1.25 divided by log of 1.5, and that gives minus 0.5503. So T1 is 150, yes, this is this term to others, 150 minus plus multiply 110 into 0.5503, yes. So that gives 89.5 degrees centigrade. So temperature halfway through the covering is 89.5 degrees centigrade, which is final answer of this problem. So next problem, number 3. Long hollow pipe has an inner diameter of 10 cm and outer of 20 cm. The inner surface is kept at 200 degrees centigrade and the outer surface is at 50 degrees centigrade. The thermal conductivity K is equal to 0.12. How much heat lost per minute from a portion of pipe 20 meter long? Find the temperature at a distance x is equal to 7.5 centimeter from the center of the pipe. So we have to apply formula first, then we have to see that what is given. When x diameter is 10 means radius is 5. When x is 5, yes, and yes, diameter outer and outer of hollow pipe has inner diameter 5, yes. So it is when x is 5 is 200, when x is 10 is 50 degrees centigrade, thermal conductivity K is 0.12, and we have to find heat loss per minute from a portion of pipe 20 meter long. Also we have to find temperature at a distance x is equal to 7.5 centimeter from the center of the pipe. So we first apply standard formula, which is Q is equal to minus Ka dt by dx. And here, since we have given a pipe which is circular, therefore A is 2 pi x. So dt is equal to minus Q divided by 2 pi k into dx by x. So given that when x is 5, t is 2. When x is 10, t is 50 degrees centigrade, which is shown in the diagram. So here when x is 5, it is maintained at 200 degrees centigrade. When x is 10, it is maintained at 50 degrees centigrade. So we have to find Q. For that, we will write this equation again. dt is equal to minus q divided by 2 pi k dx by x. Since we need to integrate it, and limits we can obtain from this. When x is 5, t is 200. Yes. When x is 10, t is 50. and you solve this now. So we'll write this equation as it is. Then left hand side integration is t from 50 to 200, means 50 minus 200 is minus 1. Right hand side will be q divided by 2 pi k log of x, integration of dx by x, log x. Limits are from 5 to 10. So it is minus q divided by 2 pi k log 10 minus log 5 is log of 10 by 5 is log 2. So that gives minus 150, which is equal to minus q divided by 2 pi k into log of. Say this is equation number 1. From this you can calculate q, which is equal to this. Taking minus sign is not. Minus 1, it is 150 into 2 pi k divided by log. Minus sign is not, because minus of minus will be this. So this negative sign is not there, it should be plus. So which is equal to 150 into 2 into 3.14 into k means 0.12 divided by log. So it is, if you simplify this product, you will get numerator as 113.04 divided by this will be 0.693, and finally answer is 163 degree. Yes, q is equal to 163 calorie per second. So that is our value of required value of q. Now again we write equation number 1, which is 150. Yes, 150 is equal to minus 150 is equal to minus q divided by 2 pi k log. Yes. Using another condition, when x is 10, t is 50. And when x is 7.5, we have to find what is temperature there. So when x is 7.5, we will assume t is equal to T1. So dt, which is equal to minus q divided by 2 pi k dx by x. Lower limit when x is 5, t is 200. X is 7.5, we assume t is equal to T1. Integrate this. So left hand side integration is T1 minus 200. It's very obvious. Right hand side will be this part as it is. Minus q divided by 2 pi k. And integration of this is log x. From 7.5, from 5 to 7.5. So this will be minus q divided by 2 pi k log of 7.5 minus log 5. That gives log of 7.5 divided by 5. That gives log of 1.5. So we denote this by equation number. This is equation number 1. And we take ratio 2 by 1. So it is minus 150. Yes, 2 means T1 minus 200 divided by 150. And this is minus q divided by 2 pi k get cancelled. Negative sign will be there. This will be log of 1.5 divided by log. Why negative sign? Because this negative sign is there. So it will be transposed to other side. So we have 2 divided by 1 ratio to find. It is T1 minus 200 divided by 150, which is equal to minus log of 1.5 divided by log 2, which is minus 0.5849. So T1 is, shift this term to other side. So it is 150 into this factor 0.5849 with negative sign, and 200 is, if you shift to other side, it is 200 minus this. So it is T1 is 200 minus 150 into 0.5849, and that gives 112.74. It's approximately equal to 113 degrees centigrade. So that is a final answer of this problem. As it is already said, practice makes man perfect. So therefore do more practice of such type of problems and definitely you will be successful, or you will be successful while solving the problems based on Fourier law of heat conduction. So I am giving one problem as an assignment. You can note down this and you will try your level best to solve this. Pipe 10 centimeter diameter contains a steel at 100 degrees centigrade. It is covered with asbestos 5 centimeter thick, for which K is equal to 0.0006 and outside surface is at 30 degrees centigrade. And the amount of heat lost per hour from a meter long pipe, and verify your answer. So with this, I wish you all the best, happy learning, and thanking you for listening this particular video.